Under certain situation, the status of an object should not be changed after it has been initialized. We have discussed the security issues and the controls related to mutability for a Java object that is used as a key for the map connection. Whenever the status of an object is changed, it may introduce inconsistency for various access operations. Therefore, if the object is subject to potential change, then a defensive copy is needed. So a mutable class should provide a copy constructor or a public static factory method for users to create a copy of an instance. If its class is defined as final class, then it needs to make sure that the copy function will override the clone method. In this case, a program needs to provide its own clone method instead of using the clone method defined in Java non-object class. We have discussed that the clone is secure only for final class. Non-final class should not take this approach. Now, I would like to show a Java example. First, take a look at the non-compliant solution. The mutable class defines a private member variable date D, which is a date object, and the getDate method. In the main method, we create one mutable class object, then call the getDate method. After that, the value of the data object is printed out. After the printout, we then change the state of the data object date, and then call the getData method and print out the value of the data object. As you can see, somewhere the values are printed out. How can we address this security issue? To secure the object mutability, whenever a user accesses data object, the user will obtain the clone of such data object instead of the object itself. Let's run the compliant program. See what happened. The results showed that with the defense copy mechanism, no change has been made to the original copy. The program printed out the same date, time values of data object before and after the update. Please note that this mechanism may be still vulnerable. Other approach is to make the data object date to be final. Then you cannot change that data object. If the program really needs to update the object, in this case, the data object, then the program can always get another copy or make a defensive copy. There are multiple ways to make a defense copy. One way is to have a defense constructor. In this program, we have two defense constructors, one with the mutable class object, which will create a clone of data object member of the mutable objects. The other with the data object, which will create a clone of data object itself. The other approach is to create a defense copy with any of the methods that have access to that data object. Okay, that's pretty much about the secure Java mutability.